Okay, we've already talked about how to convert from molecules to moles, so now we're going to talk about how to use mass and how, since that is the more practical way of us using things in the lab, since we can put things on a balance and get the mass, how we can relate things to mass so that we can use them in a more logical manner. So the definition of molar mass is just the mass for 1 mole of an atom or a molecule. So other things that you might hear are the same thing of molecular weight, molecular mass, formula weight, formula mass. Atomic mass is another one that you'll hear. So here the average atomic mass is equal to the grams for 1 mole, and this is found directly on your periodic table. Okay, so if we have an element and we want to know its mass of 1 mole of carbon atoms, we look at the periodic table, we find C, and right next to it or underneath it we see 12.01 grams. So that would be the molecular mass, the molar mass, the average mass of 1 mole of carbon atoms. For oxygen, we would look under oxygen and it's 15.99 or 16.00 grams. If we look for hydrogen, it's 1.01 grams, and so again, you would just have to look at your periodic table. You will also see these sometimes labeled grams per mole or grams per mole this way. Sometimes you'll see just grams. Any of those are acceptable because it's always how many grams are in 1 mole. So that's where this comes from. So the molar mass for molecules, that's equal to the sum of the molar masses of all those atoms. So how do we do this? We just add them up. So we count the number of each type of atom. We find the molar mass on the periodic table. We multiply how many atoms we have times the mass, and we then add them all together. So here's an example for calcium bromide. Okay, we have 1 calcium, we have 2 bromine. We find calcium's mass on the periodic table. It's 40.08 grams per mole. Always use 2 decimal places when you write down your masses. Bromine we look up, 79.91. Third step is to multiply these. So 1 times 40 and 2 times 79.91. We get both of those numbers and then we add them together to get our total molecular mass for a molecule. So 199.90 grams per mole in this case. Okay, let's say we have something with a polyatomic ion in it with a parenthesis. So how do we figure out how much this molecule weighs? Well, we have 1 strontium. Anything inside the parentheses is going to be multiplied by the subscript outside of it, so we have 2 nitrogen, and then that means we would have 6 oxygen. Again, we look up our molar masses from the periodic table. We find those for all 3. We do our multiplication, get those 3 answers, and then we're going to add those all up together to get our final mass for this compound of 211.64 grams per mole. So how do we find the molar mass for aluminum hydroxide? Same way. Where there's 1 aluminum, here there's a 3 outside our parentheses, so we have 3 oxygens and 3 hydrogens. Look up those masses off the periodic table, do our multiplication, add those 3 up together, and we get 78.01 grams per mole. How do we use this in conversions? Well, we know that 1 mole is going to be equal to our molar mass. So here's a question. How many grams are in 1.25 moles of water? Well, if we have 1.25 moles, we want to get to grams. We look at our conversion factor. If we add up the mass of water, okay, we take how many atoms times the mass, add those together, we get 18.02 grams per mole. So we know for water, every 18.02 grams is per 1 mole. And so we can set that up into our conversion factor here. We have 1 mole here, moles here cancel, and then we have this many grams per 1 mole. Multiply through, and we get 22.53. We have 3 significant figures here and 4 here, so we need to round this to 22.5 for our final answer. So if we're going from grams to molecules, this is a little more difficult because we have to relate everything to moles. So we would write down our grams. We know we want to get to molecules. So we're going to have to take 2 different steps here. We know when we add everything up that it's 58.44 grams per 1 mole. And then we would have to relate that to how many molecules are in a mole. Okay, so we take our grams, we look here, we would plug in our grams that we know from adding it up on the bottom. So those would cancel out, and we know that's per 1 mole. So the 1 has to go on top. Then we're in moles because our grams have canceled out. We need to get to molecules. So now we know 1 mole is equal to Avogadro's number. So we take our 1 and plug it in for moles here. So these two will cancel out. And then we'll end up with our molecules on top, plugging in Avogadro's number to go along with that. So to work through this, we would take into our calculator 25.5, multiply that times 1, and then multiply that times 6.02, caret key 23, and hit our equal sign. And then we're going to have to divide by 58.44 because that's on the bottom. If we divide by 1, it's not going to change anything. You can see here all of our labels canceled, and so we would end up with an answer of 2.63 times 10 to the 23rd. 3 significant figures here, 4 here, and 3 here, so we get 3 in our answer. So how many moles are in 25.5 grams of NaCl? We add up our mass again. We know that 1 mole is equal to that mass. We put our grams on the bottom, so grams will cancel out. We put our 1 mole on top, and we take 25.5 grams. We multiply it times 1 and divide it by 58.44. We get 0.44. There's 3 significant figures here, 4 here, so this technically should be 0.440 moles of calcium chloride. Last example, how many grams is in a sample of 2.75 times 10 to the 24th molecules? So now we're in molecules. Again, molecules relate to moles, so we have to do that step first. So here our 1 mole is equal to Avogadro's number of molecules. Molecules have to go on the bottom so they cancel out. We know 1 mole is equal to Avogadro's number here. And then we move on. Once we're in moles here, we can take our mole and our gram here and get to what we're trying to end up with by using this conversion factor. Take our mass, add it up from our formula, plug that in, and we take our 1 mole and put that down here. Our moles are going to cancel now, and we'll end up with grams for our final answer. So you can see how everything cancels. We would take 2.75 caret key 24 times 158.52, divide that by 6.02 caret key 23, and we get our answer 7.24. 3 significant figures, 3 significant figures, 5 significant figures, so we want 3 in our answer. So that would be our final answer.